So, what we discussed in previous class about quadratic equations, right? So, we learned the type of a quadratic equation, types of a quadratic equation, pure quadratic equation, monic quadratic equation. And I told you what is quadratic equation. An equation which is in the form of ax square plus, I am just revising, so ax square plus bx plus c equal to 0, where a, b, c are complex numbers belongs to c, complex numbers, and a does not equals to 0. A does not equals to 0. Then pure quadratic equation, monic quadratic equation. Pure quadratic equation means there should not be a x term. That means x term should be removed. For that example, we have written 7x square minus 54 equal to 0. That means here x square term is there and constant term also there. But there is no x term. So this is an example for pure quadratic equation. Okay. Next, monic quadratic equation. Monic quadratic equation means x square coefficient must be 1. X square coefficient must be 1. So that means there is no coefficient appearing before x square. That means it always 1. X square plus 5x plus 6 is equals to 0 is an example of monic quadratic equation. Then we discussed about the roots. What is that? If alpha comma beta are roots of a quadratic equation. What is root? Root is nothing but solution. That means for which value, when we substitute one value in the given quadratic equation, that entire quadratic equation must be 0. Am I right? Now that value is called solution or root of the given quadratic equation, or zeros of a quadratic equation. We can call root or 0. We can call root or 0. Am I right? If alpha comma beta are two roots, we learn the condition sum of roots is minus b by a, that is nothing but minus x coefficient by x square coefficient. Okay na? And product of roots, alpha into beta is equals to c by a. C by a is nothing but constant term by x square coefficient. So these are the topics we learned in the previous class. What is quadratic equation? Pure quadratic, monic quadratic. What are zeros or roots? Then if you take two roots, alpha beta minus b by a sum of roots, c by a is the product of roots. And that too, every quadratic equation have at most, that means maximum 2 roots. Maximum 2 roots because of its degree. Cubic means degree 3, so 3 roots. Biquadratic means degree 4, that means 4 roots. Clear? And there only I have set that a point. If a quadratic equation have more than 2 zeros, more than 2 distinct roots means different roots, more than 2 different roots, that quadratic equation will be identity. Am I right? Yeah. So in that case, if ax square plus bx plus c is a general form of a quadratic equation, for this equation is becoming an identity. Identity means it should have more than two distinct roots or more than two distinct solutions, then we are calling that it is an identity. So here a value is nothing but x square coefficient, b value x coefficient, and c value constant term, all are equals to 0. When it is happen, if that quadratic equation is an identity. Okay na? Yeah. Now coming to the today's concept, let us find, we discussed about minimum and maximum. The shape of a quadratic equation is parabola. Okay, very good. Now, today we are discussing an important topic. You already learned that a quadratic equation has two different roots or two distinct roots. The two distinct roots means there can be in any two different complex numbers. Okay na? For this, there is a possibility while drawing the graph. I am just taking a minima. It is x-axis and it is y-axis. When you draw quadratic equation on a graph sheet, it will give a parabola. Now here, the parabola touches the x-axis. At two different points, two different places. That means in this case, we have two different roots. In this case, we have two distinct or different roots. Okay. Now coming to the second. Same way, the quadratic equation only touches at one point. Touches at x-axis. One point. In this condition, we should learn that here also two roots, but the two roots are same. Two same roots. Or two same solutions. Okay na? Like that quadratic equation is in the form of a plus b whole square or a minus b whole square, like that. Okay? Two same roots. Now third, I'm writing here. Okay, third one, that quadratic equation never touches the x-axis. It is never touches the x-axis. That means there are no real roots. In this case, we can identify the real roots here. Two distinct real roots, two same real roots, there are no roots. There are no real roots. Okay, children? Yeah, once you draw a rough diagrams in your book, or you can take a screenshot. Am I audible to you? Okay. Now, next one, without finding the solution of a quadratic equation or without finding its factors, can we say the given equation has two roots or two distinct roots or two same roots or no roots condition? Can we say that? Yeah, we have an option. That option is called discriminant. That option is called discriminant. Okay na? This discriminant we have to represent with the letters delta. It is looking like a triangle or capital D. So nothing but discriminant is b square minus 4ac. What is this, sir? B square minus 4ac. This condition we are taking from the general form ax square plus bx plus c equal to 0. Here b means what? X coefficient. A means x square coefficient. C is constant term. Okay na? So this will be given that from this discriminant delta, the discriminant value, there are three cases. So case 1, because while I am drawing the diagram, there are three different diagrams which is having two different roots, two same roots, no roots. For the three cases, if delta value is greater than 0, we have delta value is greater than 0, we have two distinct roots. Nothing but discriminant is 0, sorry, greater than 0. The discriminant value is greater than 0. We will get two distinct roots. Discriminant, case 2. Discriminant is equal to 0. We are two same roots. Okay? Discriminant is equals to 0. We have same roots. Now case 3. Discriminant value less than 0. Either it should be greater than 0 or less than 0, equal to 0. Only three conditions, right? So greater than 0 means two different roots. Equal to 0, same roots. No real roots. Less than 0 means no real roots. That means the roots can be in complex numbers. Very, very important condition, this one. Okay, children? Right. Now, we have a condition, right? In previous class, we learned that if alpha comma beta are, I am writing again, if alpha, beta are two roots, we found that sum of roots alpha plus beta equal to minus b by a, alpha plus beta equal to minus b by a, and alpha into beta equal to c by a, right? That means if you know already two roots, we can find a quadratic equation easily. Okay na? By using this, therefore the equation is, then the equation is x square minus alpha plus beta into x plus alpha beta equal to 0. Very, very important. If you know already the zeros are roots, then the quadratic equation will be in the form of x square minus alpha plus beta into x plus alpha beta. Okay? Now here only we are doing some problems. Now we go for the next topic. Now, let us take one example. If two comma 3 are roots of a quadratic equation, find the quadratic equation. Find the quadratic equation. Okay, na? Now see that one. If you know already the roots, we have to substitute in the equation x square minus alpha plus beta into x plus alpha beta equal to 0. Now writing the solution. What are the given roots? 2 and 3. So one I am taking as alpha, second one is beta. Now what do we need? Alpha plus beta we should find, alpha into beta we should find. Now alpha plus beta equal to 2 plus 3, that is equal to 5. Now alpha into beta equals to alpha into beta So 2 into 3, 6. Therefore the quadratic equation is x square minus alpha plus beta into x plus alpha beta equal to 0. Substitute the values. X square as it is x square minus, what is the alpha plus beta value we got? 5. So 5 into x is 5x plus alpha into beta value is 6. Therefore the required quadratic equation is x square minus 5x plus 6. Okay children, if you know the roots, we can find the quadratic equation like this. Please note it. And afterwards do this problem. Second sum same. 5 comma minus 3 are roots. Find QE, quadratic equation. Now roots are given 5 and minus 3. Find the quadratic equation. First you note this problem, then try for second one. Do it children. Yeah, got the answer? What are the roots I gave? 5 and minus 3. Second problem. So alpha value 5, beta value minus 2. Now what to find first? Sum of roots. Sum of roots means alpha plus beta. Alright. Alpha plus beta. Substitute alpha is 5 plus beta value minus 2. That is equals to 5 plus into minus. Here bracket indicates multiplication symbol. So plus into minus, minus 2. 5 minus 2, 3. So I got the alpha plus beta value is 3. Now alpha into beta value. Alpha value is 5 into beta value is minus 2. So 5 is positive number, 2 is negative number. So plus into minus becomes minus, 5 2s are 10. Now QE. What is the quadratic equation? X square minus alpha plus beta into x plus alpha beta. plus alpha beta. Okay na? Find it, substitute. Therefore x square minus alpha plus beta value is 3. So 3 into x, that means 3x, plus minus plus alpha into beta. Alpha into beta is minus 10. So front we have plus symbol, that is equal to 0. Therefore the given equation is, the required equation is x square minus 3x plus into minus becomes minus 10. This is the required equation. For explaining you, it is taking more time, but while you are doing it, it will be easy only for you. Within the minute you can do it. Okay na? Can you do one more? Oh, I can write. Okay. Now here, do third one, children. Third. Same. Now alpha value directly I am writing direct values. Alpha value is 7. Beta value is minus 4. Find it, children. 1 minute. For your 1 minute time. Completed? The answer is x square plus 3x minus 28 equal to 0. It should come like that. Okay? Next. Right. So if you already know the roots of a quadratic equation, how to make a quadratic equation, that is one model you will learn now. Okay, na? You already know the roots of a quadratic equation, we can find what is the quadratic equation related to that roots. Now, if the quadratic equation is given, how to find its roots? How to find its roots? Mainly for solving a quadratic equation, for solving a quadratic equation, we have three different methods. First method is factorization. First method, factorization. That means the given quadratic equation is written as product of its factors. Product of its factors. Second one, we can use completing square method. Completing square method. Okay, na? Completing square method. And last one, using formula. These are the main three ways to find a quadratic equation. Sometimes factorization won't be work out. That means if a quadratic equation having the factors in the form of complex numbers or non-real numbers, like third case, b square minus 4ac less than 0, I said no real roots. No real roots means roots will be there, but the roots are in the form of complex numbers. The roots are in the form of complex numbers. In that case, we cannot find the factors by using that factorization. By using the factorization method, then we use easily formula. Okay, na? What is that formula? How it came? The derivation I will write and show you. Derivation of a formula for finding the roots of a quadratic equation. Okay, children? Okay. Now, same process we are telling for completing square method only. The process we are following to find the formula is nothing but completing square method. That means the given quadratic equation, we have to write it as a plus b whole square form or a minus b whole square form. Any one of the form we have to make it. Okay, na? A plus b whole square or a minus b whole square. Then we will get the formula. Okay, na? Yeah, let us check that. I am starting a new page. Okay. Yeah. So the general form we know, ax square plus bx plus c equal to 0. Very important, children. Now, here x square term, x term, constant term. Three terms are there, no? First transpose the constant term to right side. That means ax square plus bx equal to plus c transpose that side, it becomes minus c. Okay, na? And you transpose plus c, it becomes minus c. That is step 1. Now step 2, the x square coefficient must be 1 always. X square coefficient must be 1. So, but what is the x square coefficient here? A. So, I don't want a. So, divide a both sides to make the x square coefficient 1. I am having extra element a. I am dividing a because a is multiplying here. Divide a both sides. Okay, na? So that means ax square by a plus bx by a equals to minus c by a. Now these two cancel. Now the equation is in the form of x square plus b by a into x is equals to minus c by a. Right. Two steps completed. First step, constant term we are transposing that side. Step 1, constant term is transposing that side. Step 2, x square coefficient we are make it into 1. X square coefficient a, I don't want extra element a. So that's why I divided with a. Okay, na? So now x square coefficient is 1. The resulting equation is x square coefficient is 1. Now the third step is we are writing this equation as a plus b whole square format. A plus b whole square format. What is a plus b whole square formula? A plus b whole square formula, a square plus 2ab plus b square equals to a plus b whole square. We should make this into this format. See, we have x square term is there, x term is there. Square term, x term. Still we want constant term. Yeah. From here onwards, we should find the constant term x square. So this x square I can write it like this, x whole square. Okay, na? Both are same, x square or x whole square same. That means a square term we find plus 2ab term. 2 not there, but x term is there. That means here x is nothing but a only, no? Or for understanding, I am writing x plus a plus b whole square instead of x plus y whole square. Okay, now you will understand clearly. Right, a square term is there, 2ab term should get, 2 not there, 2 multiply and divided. I am multiplying 2 and dividing here. Okay, without changing its value, is equals to minus c by a. So a square plus 2ab, a means x only here, a square means a means x only. So this is b term, b by 2a. So a square plus 2ab we got. Now b square we should get. B already we know, b by 2a. So add b square both sides. B square means what? B square means b by 2a whole square, both sides. Now it will be a square plus 2ab plus b square. B square means b by 2a whole square. Right side also we should add. So minus c by a plus b by 2a whole square. Now left hand side is in the form of a plus b whole square. A square plus 2ab plus b square means a plus b whole square. That means x plus b by 2a whole square. Okay, na? That equals to, simplify this RHS part, minus c by a plus b by 2 whole square means b square by 4a square. B square by 4a square. That implies x plus b by 2a whole square equal to, now what is the LCM of 4a square and a? 4a square only. So we have to multiply its numerator with 4a. A only we have the first denominator. So total LCM 4a square. We have to multiply with 4a. So it will be minus 4ac. 4a into c minus 4ac. Plus b square. Okay, na children? That implies x plus b by 2a whole square equal to, write its order. First b square term, then minus 4ac term. So it will be b square minus 4ac by 4a square. Now apply square root both sides. That means x plus b by whole square equal to b square minus 4ac root over b square minus 4ac by 4a square. Apply square root both sides. Square root to cancel it. The answer is x plus b by 2a. When you apply the square root here, we'll give the plus or minus symbol. Root over b square minus 4ac by root over 4 means 2, root over a square means a. That's it, last step. X is equal to plus b by 2a, transpose the side, minus b by 2a plus or minus root over b square minus 4ac by 2a. Both are having the same denominator, so apply this. Minus b plus or minus root over b square minus 4ac divided by 2a. This is the formula. Here only we found the discriminant. Okay, na? Yeah, please take screenshots, these two.